Greetings. I'd like to show you something I found on the web. It's a little project I built. It's a paddle, it's a Morse code paddle with dits and das. It's not my design, it's a VK3IL's, and he published all the details on his blog, and I put the address in the description below. It's a Morse code paddle and it's electronic. It's not mechanical, so it's very good and lightweight, very thin to carry around in a portable situation, and it works very well. And I'll show you the schematic in a minute, but I'd like at least to show you how it's built first. And it's basically a PCB with a couple of MOSFET transistors of a special grade, very low VGS transistors, and a couple of pull-ups and filtering capacitors. But the heart of the machine is really these pressure sensors, like tactile pressure sensors. They respond to a force of 20 grams or more, so it's not a lot. So the exact model for this pressure sensor is the RP-C18.3-ST, and you can find these for around $3. So you need a pair, one for the dits and one for the DAWs. And the PCB itself, I took VK3IL's design, so he does provide the Gerber file, so I just sent the design to JLC PCB and got 5 of these PCBs in 12 days for a total of $4 including shipping. So really cheap for these PCBs. And yeah, I got it in 12-13 days as opposed to maybe 7 or 8 days if you take a more expensive courier. But if you're not in rush, why not? Pay much less for the bare PCBs. So I don't know if this offer is still available. Up to you to check. But in any case, even at $20 for 5 PCBs, you can maybe share with friends and bring down the cost of your bare PCB. So yeah, one sensor per side. You really manipulate like this, dits and das, like you would for a regular paddle. Let me show you the final result. I've taped up the area where there's electronics. You don't want to short out anything. So all the metal parts are covered. And I used a regular 3.5 millimeter, 1/8 inch stereo plug. And there you go. It's really lightweight and it works great. Let me show you how it works. So here's a True SDX a multiband QRP transceiver, and here's a demo when it's connected to that radio. So forget about the raspy sound. It's not the paddle, it's really the small speaker in this radio, which doesn't have great audio. You don't press any harder than you would on a regular mechanical paddle, really, and you hold it with one hand and just go back and forth with the second hand. Works very well with this radio. It also works fine with the IC705, which I also own. Apparently some people had issues with the IC705. All I can say is make sure you buy genuine transistors. And for me, I built 2 of these, and they both work fine on the IC705. Okay, so this is good only for low voltage radios that have like logic level inputs for the dits and DAWs. It's really meant to be connected up to modern radios. You won't switch any tube type radios unless you make some modifications on that paddle. And of course it uses the keyer that's built in to the radio. So now let's look at the VK3IL's blog, and you'll see the schematic and everything else. Here's VK3IL's blog page that covers the pressure paddle V2. That's what he calls it. And there are 2 versions for the PCB. The shorter one, which I used, and then there's a longer version. It's 10 centimeters long. This one I think is 6 or 7 centimeters long. I preferred the shorter one, but it's exactly the same circuit, just a longer PCB. For those who have big hands and prefer a longer PCB. So the schematic, twice the same circuit. It uses a BSS 806N These are called very low VGS, so very low threshold voltage for conductivity of the transistor. It's as low as 0.5, 0.6 volts to trigger a conduction of the transistor. So it's important to have this. Why? Because we have very little voltage available on the DITS and DOS signals coming from the radio. Usually it's either a TTL 5 volt signal, but it can even go as low as around 3 volts for the IC705. And you want to have a voltage that's low enough to trigger the two inputs, either DITS or DOS. You want a low voltage here. And the only way to achieve this is to have a very low VGS MOSFET. And this is how it works. Your sensor is here, and there's a pull down of a very high value. Of course, the voltage, which would normally be kept around 0, so transistor is no conductivity, VGS is almost 0. When you apply pressure here, it brings up this gate voltage because it's a voltage divider, and this value goes lower in ohmage, which will pull the voltage higher. But it will pull it as high as the VGS threshold voltage is. So in the end, there's an equilibrium that's created, and the voltage here, when you apply just enough pressure on that sensor, the voltage that's going to be here on the drain is going to be pretty much identical to the VGS voltage, which will be less than 1 volt, maybe around 0.9 volts, which is enough to trigger the input of the electronic radio, since it's a logic gate and it has a pull-up internal to the radio to the supply. Usually that's how it's done, right? It's a logic input and there's a pull-up to keep the level high, so non-triggered by default. So that's all it takes, a bit of current coming from that internal pull-up, internal to the radio, to flow into the transistor when enough pressure is applied on the sensor. Twice the same circuit, a bit of filtering for high frequencies just in case, and that's it. So here's his board shown here. He elected to use red PCBs, up to you, color doesn't matter. And what he did is he covered with heat shrink tubing. I didn't have a lot of success with heat shrink. It would wrinkle on the edges, and I didn't like that. His seemed to be a better grade of heat shrink. In any case, I decided to use Kapton tape, green Kapton tape instead. And there you go. You can tie up your cable to make sure it takes the strain off the ends here, and you're in business. Provides the Gerber files for 63mm or 100mm. And as far as the part list, they're provided here. He recommends the BSS 806 transistor, but there are other transistors that could do the job. But like I said, these are kind of special. A 2N7000 or 7002 small signal MOSFET will not work in such an application. You want a very low VGS transistor. Just buy the BSS 806. I bought some on AliExpress, a lot of 10, and they work very well, surprisingly. I have BSS 806s ordered from DigiKey and ordered from AliExpress, and they both work fine in this circuit. So very few parts in the end, very simple circuit, and it works great. All for now. 7-3.